In this section, we will talk about how the U.S. invented a new explosive called CL-20 with 40% greater penetrating power and propellant range than conventional explosives, but failed to develop and deploy it due to lack of urgency after the Cold War. CL-20 stands for China Lake Compound No. 20, named after the Naval Surface Weapons Center at China Lake, California, where it was first synthesized in 1986 by Arnold Nielsen. CL-20 is a polycyclic nitroamine explosive with the formula C6H6N120. It has a better oxidizer-to-fuel ratio than conventional explosives like HMX or RDX. CL-20 releases 20% more energy than traditional HMX-based propellants, and has a detonation velocity of 9,660 meters per second and a density of 2.04 grams per cubic centimeter. This means that CL-20 can create more powerful explosions with less material and weight. For example, a 30-gram CL-20 shaped charge can penetrate 40% deeper into steel blocks than a 30-gram HMX shaped charge. CL-20 was considered a breakthrough in explosive chemistry and had potential applications for rocket propellants, missiles, bombs, and other weapons systems. It could also reduce the environmental impact of explosives by producing less smoke and toxic gases. However, CL-20 also had some drawbacks that hindered its development and deployment. One of them was its high sensitivity and instability. CL-20 is more sensitive than HMX and closer to PTN, one of the least stable of the modern military explosives. This means that CL-20 is more prone to accidental detonation by shock, friction, or heat, which poses a risk for storage, transportation, and handling. Another drawback was its high cost and low availability. CL-20 is manufactured in small batches of about 100 kilograms by Thiokol and the French SNP. The cost in kilogram lots is quoted at over $1,300 per kilogram, which is much higher than the $100 per kilogram for HMX. CL-20 also requires complex synthesis and purification processes that involve hazardous chemicals like nitronium tetrafluoroborate and nitrosonium tetrafluoroborate. The main reason why CL-20 failed to become a widely used explosive was the lack of urgency after the Cold War. The U.S. military did not see a pressing need for more powerful explosives when the threat of nuclear war was reduced. The development of CL-20 was slowed down by budget cuts, safety concerns, and technical challenges. CL-20 has not yet been fielded in any production weapons system, but is still undergoing testing for stability, production capabilities, and other weapons characteristics. CL-20 is an example of how the U.S. invented an incredible new explosive that could have given it an edge in future wars, but failed to exploit its full potential due to political and economic factors. While the U.S. was the first to invent a new explosive with incredible potential in the 1980s, it failed to capitalize on its discovery and let China take the lead. The explosive, called CL-20, was developed by the China Lake facility in California, and had up to 40% greater penetrating power and propellant range than the conventional explosives used by the U.S. military. However, after the collapse of the Soviet Union, the Pentagon lost interest in developing CL-20 and designing weapons to use it. China, on the other hand, saw the potential of CL-20 and invested heavily in developing long-range missiles with the aim of forcing U.S. warships and non-stealthy aircraft to operate at a distance if Chinese forces invade Taiwan. Some of those weapons are believed to be propelled by a version of CL-20, which China first fielded in 2011 and now produces at scale. This gives China an edge over the U.S. in terms of firepower and range, as CL-20 releases 20% more energy than traditional explosives and has a better oxidizer-to-fuel ratio. The U.S.